In this video, we'll take a closer look at titrations and calculations involving titrations. A titration is an analytical lab technique in which a standard solution is used to determine the concentration of an unknown solution. The standard solution is used as the titrant in the titration. It is the substance that is added to and passed through the burette during the course of the titration. The equivalence point of the titration is the point at which stoichiometric equivalent amounts of the hydrogen ion and the hydroxide ion have been combined. The endpoint of the titration is the experimental point where no more titrant should be added, and this is determined by an indicator that changes colors. There is also a dramatic change in pH at or near the equivalence point. The equation we use when solving titration calculations is the following. The molarity of the acid times the volume of the acid times the number of hydrogen ions present in the formula of the acid is equal to the molarity of the base times the volume of the base times the number of hydroxide ions that are present in the formula of the base. Here's an example of a titration calculation. 41.3 milliliters of a 1.5 molar sodium hydroxide solution are required to neutralize 45.0 milliliters of sulfuric acid. Find the molarity of the sulfuric acid. We will be using the titration equation that we just went over. We set up a data table where we indicate what's given to us and what we are trying to solve for. For the hydrogen ion, which relates to the sulfuric acid, what we know is that the volume of the acid was 45.0 milliliters. The N is the number of moles of the acid, which actually refers to the number of hydrogen ions that are present in the formula of the acid. And that number is 2 because the formula is H2SO4. We do not know the molarity of the acid. That is what we're trying to solve through the calculation. For the base, or the hydroxide, what we know is the molarity of the base is 1.5 molar. We also know that 41.3 milliliters of that 1.5 molar solution was required to complete the titration. For N, the hydroxide, we put a 1 because there is one OH in the formula for sodium hydroxide. When we plug in the given values to the titration equation and solve for the molarity of the acid, we find that the sulfuric acid has a molarity of 0.69 molar. Here is another titration problem. 26.2 milliliters of a 1.8 molar sodium hydroxide solution are required to neutralize 25.0 milliliters of hydrochloric acid. Find the molarity of the hydrochloric acid. So, as in the previous question, we're going to use the titration equation. We'll tabulate the data that we're given and what we're going to solve for. For the acid, or the hydrogen ion, we know that 25.0 milliliters of the hydrochloric acid was titrated. For N, we choose 1 because there is one hydrogen in the formula of HCl. We don't know the molarity of the acid. That's what the question is asking us to solve for. For the base, the hydroxide, we know that the molarity is 1.8. For the volume of the base, we know that it took 26.2 milliliters to reach the end point of the titration. For N, we would choose 1, again because we are using sodium hydroxide and there's one hydroxide in the formula. Taking all the given values and plugging them into the equation and solving for the molarity of the acid, we find that this hydrochloric acid solution is 1.9 molar. Here's one for you to try. 35.0 milliliters of a 2.0 molar calcium hydroxide solution are required to neutralize 20.0 milliliters of sulfuric acid. Find the molarity of the sulfuric acid. When you're ready, press pause, try the problem on your own, and then press play and check your work. Did you get 3.5 molar for the sulfuric acid? If you did, good job. Here's how we solve for this. For the acid, the hydrogen ion, what we knew was that 20.0 milliliters of the sulfuric acid was titrated. For H2SO4, we chose a 2 for N because there are 2 hydrogens in the formula. Again, we were trying to solve for the molarity of the sulfuric acid, so that was our unknown. For the base, or the hydroxide, we knew the molarity of the base was 2.0 molar. We knew that 35.0 milliliters was required in terms of the volume of the base. For N, we chose 2 because in calcium hydroxide, there are 2 hydroxides in the formula. So when we took all of those values and plugged them into our titration equation, that's how we found that the molarity was 3.5 molar for the sulfuric acid. And that's a closer look at titration calculations. For more chemistry matters, go to our homepage where the entire series is available to you.